Hello, everyone. You are welcome to today's lesson. The first part of today's lesson is going to be a very short one. We are going to look at the solution to the lesson 3 assignment on vectors. Okay, and just as you have on your screens, we have the solution provided. You can see some marks, okay, attached to the solution. So indirectly, we are dealing with what? A marking scheme, which will guide you to equally mark. So as usual, I've told you anytime you read questions, make it a point to underline the salient point, okay, or part, if any. So here you've been given these 4 free vectors, and you are asked to use these free vectors to find A, the vector AE, then B, the vector EA. Okay, so quickly, let's go and look at the ideal solution to question 1. When we are going to solve question 2, to read it, then look at the solution together. So I've told you, after reading any question, the first thing that you write, and underlining the salient part, the first thing that you write is what solution. After solution, you extract what you are provided in the question or provided for in the question that will help you deal with the solution. So here you will need all the vectors. So you extract that. So you extract also, it's just like copy and paste. So you write given, then or you can choose not to write the given, but this must be stated. So when you do that, okay, B1, a low hanging mark, just copy and paste for you to get 1 mark to. If you can't get it, then I don't know. Okay, then we come to, okay, the A. We are looking at solution to A. When you are moving from 1 to the sub question number A here, you don't leave any space. Take note. This is a major question and you are moving from a major question to a minor. So you don't leave. You only leave a space when you are moving from a minor to a minor question. So you come and write therefore, because I can find this straight away, the vector AE will be equal to, remember I advised you, whenever you encounter such a situation, draw. So here we realize that we have how many distinct points? 5 distinct points. So you draw this, then you indicate your arrow. So you appreciate this from the previous words lesson. So when you are able to draw this and you indicate the arrows and the vertices, your point, okay, that will be B1. If the arrows are not indicated, you had that drawn, the vertices are indicated, and you get B half. Okay, so any error, be it omission of arrows or omission of the vertices, will be minus half, okay, for each error. So if you omit the vertices, omit the arrows, then you get B0. Okay, if you don't draw it to, it will be B0, take note. So here we know that for you to move from A to E, okay, you can go through A to B, B to C, C to D, then D to what? E. You have to go through this. Remember the advice. Okay, go through the short route if possible, okay, or the route that will not oppose any direction of the original vector. So here, this would be the long route, but because it's in sync with the direction of the original vectors, we decided to go for that one. So it means if I sum all the given vectors here, I'm going to get my AE. So AB plus vector BC plus vector CD plus vector DE will give you your AE. You should know. So you come and substitute the corresponding vectors given. Then you simplify. So when you combine corresponding components, you are going to get 7 minus 2. So the S component will be, sorry, did I say 7 minus 2 minus 7? The S component will be 2 and the Y component will be minus 7. So because therefore is here, I've already drawn my conclusion. So that will be A1. Look, take note of the marks, okay, assigned. Then B, therefore, you know that the vector EA, okay, per the negation or inverse of vectors, we realize that EA will be equal to, okay, the vector what? AE. So EA will be in this direction. Meanwhile, we found AE. So if you know AE, just negate it and that will give you EA. So the vector EA will be equal to negation of vector AE. So that gives us B1. Okay, then your substitution will give you M1. You come and substitute that. You push the negative through and that gives you this as your A1. That will be it for question 1. Okay, we are through. Now, if you come to question 2, if R is the midpoint of the vector PQ, find the position vector of R. So here you underline position vector of R. You were not asked to find the coordinates of R or the point R. You were asked to find the position vector of R. Okay, so it means your conclusion must be stated in vector form. Your R must be in its vector form. Take note of that. So after that, what do? You come and extract again. So you extract the two given points. So this one will give you B1. Copy and paste, simple. Okay, get this. Then remember I told you any points that you are given and you realize that you will need a point to deal with a vector situation. The question indirectly is a vector question, but you've been given point. You know that I told you the advice is move the point from, okay, to its what vector representation. So what do? I know the vector representation of each point. Each point is a position vector. So instead of using small p tilde, I use OP vector, which is this, and it should be in column form. Okay, OQ vector, which is this. So if you don't write this, okay, you are doomed. Take note. Okay, then now, what are you asked to find? You are asked to find the position vector of R. And we know that the position vector of R is either small r tilde or the vector OR. Okay, so if you want to use the special notation, then you have to use small r tilde. Okay, but I didn't use the special notation because from here, you could realize that my intention was not to use the special notation. So if I did P tilde to be this and Q tilde, then it means I want to go the special notation way, position vector notation way. Okay, so here, you know that your OR, because we said the vector, position vector of R is the midpoint of PQ. So that would be equal to midpoint of PQ. So you state it V1. And that will be equal to half of, midpoint of a vector will be the sum of the position vectors of the two vectors, sorry, the 2 points. So then you divide by 2. So it will be half of that. Okay, so at this point, you come and substitute the position vector or the vector P, the vector, okay, OQ here, you substitute. Then when you simplify, okay, deal with what you have in brackets here, the outer square bracket becomes the ordinary bracket. Then now you multiply each of the components by half, or you divide each of the components by 2, and that gives you this as the solution to question 2. Okay, so look at the marks allotted there. And again, take note. Okay, any step, this is a step. So you should have equal to, equal to, equal to, equal to. Any equal to that you omit, it will be minus half. Take note. Because I've taught you and I've advised you, I have told you, instructed, okay, always to learn to introduce your steps, okay, with equal to if you are dealing with an expression. Take note. So it applies to all that we have here too. Okay, now let's move on to question 3, if my point is well made. Question 3, okay, what are we supposed to do? We are supposed to express the vector st, which is in 8-column form, as what magnitude bearing, okay, vector. It's supposed to be vector. Okay, so please take note. I will deal with that one as well as not vectors. Because I picked it from the rest, I should have done the right editing. So take note of that. Okay, so now question 3. Again, I extract. If I extract this B half, okay, I'll need to write this as what? Magnitude bearing. And we know this is in column form. We know how to find the magnitude of a vector in the column form. So but the magnitude of what? The vector st will be equal to root of the s component squared plus the y component squared. Okay, and with this one, if the -4 is not in brackets, it will be m0. Okay, and everything here will go. Then you come to the bearing. That's where maybe you can struggle to get some marks. I remember I advised you, whether it's positive or negative, put it in brackets. So if you decided not to heed, okay, to that advice, you know it will come with a particular, okay, what do you call it, course. So take note, punishment. So after that, you know, you come and deal with this, which will give you 16. Deal with this calculator work, that will give you 48. Then you sum this root of 64, that will give you your M1, then this will give you A1. Without the units, please take note, you won't get the A1, it will be A half. Take note of that. I want to encourage you to be writing the unit. Okay, then that will be it for the magnitude. We need to find the bearing as well. And remember the bearing, we said you cannot, okay, get the bearing without drawing. So we need to draw this. And each drawing, even I think I should have stated that one in the first one, but it doesn't really the same question. I can mention it here as well. Any drawing, remember I said any line that you are going to draw must be drawn with a straight edge. And all your drawings must also be in pencil, so that in case there are any issues, you can easily erase. So avoid drawing in ink. if possible. So quickly, let me go and pick because I will need a pen. Okay, so at this point, if you come and draw, remember this will be your X and this will be your Y, which will coincide with your true north. Because you are going to deal with bearing, you have to know that, okay, the measurement will be taken from the angle measurement, will be taken from the true north, but in a particular direction. Now, let's go and see, okay, how we can get our vector. And at this point, I will address a very important, okay, information or concern here because of what I saw in some of your presentation. So this is it. Okay, so the bearing now, what do we do? You come to the vector itself. The S component is negative, so it means you have to move in this direction. But you move 4 units, so this will be 4. Okay, then you are now here. You need to move up how many units? Positive. So it's positive, so you need to move up, and that will give you, okay, 4 root of 3. So you need to move up 4 root of 3, okay, times. So that's exact. Remember, I told you to don't forget to indicate your 90 nature. And this angle here will be theta, so don't forget. Okay, so this is the theta angle. So if you look at the bearing will be the angle measured from the true north clockwise up to where you have your vector, so up to this. So you should know that the bearing will be from here to here is 90 plus another 90, 180 plus another 90, 270, then plus theta. So your bearing will be 270 degrees plus what theta. So if you're able to write this, that will be B1. Take note. And some of you had your diagram drawn this way. I don't know. Okay, you did this and you had something drawn this way. You know what I'm talking about. I don't even know how you had it drawn. Please, your line, okay, that you are going to, your vector must always be, okay, so this indirectly, let me indicate, this indirectly is your vector ST. So your vector ST must always be a diagonal line, but that diagonal line must run from the origin, okay, and move out. So please take note. Where you started, okay, and where you ended, that's where you join. You know, you started from here, you moved 4 units here, then you moved for 4 roots of 3 units up. So you ended here. So that's where you join. You don't join any other line. I guess my point is well made. You know yourself. So please make sure you take note of that so that you don't repeat this in the class test or any subsequent assignment. Okay, so at this point, okay, if I want to get theta, I have to use the right angle triangle here. The measurement here is 4. The side here is also 4 roots of 3. Okay, and please, if you wrote -4 here, it will be minus half. Take note, because I told you the side of the triangle, none of them should be negative. The negative will tell you which direction to move, either up or down, left or right. Okay, the negative attached to the components, okay, values. Okay, so now what do we have? We come here and we know we are going to deal with theta. And I advise you always use tan because you know the opposite over what the adjacent. Someone can use the ST because the person knows the magnitude of ST. Okay, so the person can use that, but I advise you to use these two. Okay, and just for the simple reason that you found the magnitude. So if the magnitude is wrong, you won't get the bearing to be wrong. But these two values here, you didn't find them. They came directly in the question, so it's better to use them. If there is anything wrong with this, okay, then the person who said the question should be blamed, not you. So like I always advise in maths, always go for a solution that will involve what is given rather than what you have found. In case it is wrong, you don't get, okay, the subsequent questions also wrong. I guess my point is well made. So opposite will be 4 roots of 3 over what? Over 4, which is the adjacent. So, but we know that tan theta. So this will cancel that, and that will give us theta to be equal to tan inverse of root of 3, which will give us what? Theta to be equal to 60 degrees. You can see the marks here. I think I should have, okay, made this one black. Okay, I will do it, but this is A1. Okay, I didn't. I think then it means it's possible I didn't count it. It might be possible. So I will go back and check, okay, and do the needful. So here, once I know my theta, I know my bearing. So this implies that the bearing will be equal to 270 degrees plus the theta, which is 60 degrees. And that will give you 330 what degrees. Okay, that will also be A1. So now, therefore, your vector ST in its magnitude bearing form will be equal to, in bracket, you state the magnitude, which gave us 8 units, then the bearing, which is 330 degrees. Okay, take note. That will be it for the solution to question 3. Now to the last question, question 4. That was the easiest. It's just a formula work. Okay, so given this, that is B half. Okay, now what were you asked to find? You were asked to write this in terms of what column, or as a column vector. Okay, so now what do? We have to quickly use the formula. We know that the vector ST in terms of its column, when it comes in the magnitude bearing, will be the magnitude of the vector sine the bearing. So the magnitude of the vector is a sine, the bearing is 330 degrees. And please take note, the bearing is 330 degrees. So someone wrote 33. Meanwhile, you stated 330 here. So it means at this point you are lost. Take note of that. Okay, and I told you that the only zero that you omit will be the zero in the bearing angle that comes before your, what do you call it, significant number. So if it was 0, 3, 3, then I said degrees, then you ignore the 0. But if the 0 comes after that, it's the 0 that is before. Make it like a 3-digit number that you ignore. So if maybe you got it wrong, that's the more reason why you ignore this 0. Then now I'll put you back on track. So next time you don't do that, only that you'll be penalized because I guess I was emphatic. So then 8 cos of your angle, which is 330 degrees, your bearing angle. So the rest will just be calculator work. Use your calculator to do a sine 30 degrees. That will give you -4. Use your calculator to do 8 cos 30 degrees, and that will give you 4 root of 3. So you can see that it's basically the same vector, okay, that I gave here. I wanted you to go back and see. So this, okay, was the column form that I asked you to take it to magnitude bearing. Then I gave you the magnitude bearing to take it back to this. So you can see that indeed, okay, that is very critical. So in view of that, let's quickly, okay, deal with the situation. So let me go and deal with the situation there. I guess now the mass, the total mass will be 31. I guess. Okay, because it seems I didn't factor this. Okay, so let me pause, then we will all check. Okay, then we'll come back and continue. Do the needful. So let me pause. No, okay, so I've gone to do the needful. Okay, so the A1 here has been catered for. But when we brought in the A1, the total marks was 31. So because of that, this now, the diagram will be B, okay, 1, and this will also be M1. Initially, it was M1 and half, B1 and half, so that it will still be 30, okay, marks. So please take note, and that will be it. Okay, so at this point, and please here, you know, anytime you, some of you I know will not simplify this, which I saw. Okay, if you don't simplify it and come and write it again, it will just waste your time. But before you write it here, check whether you can reduce next time. So you will not be penalized. You get the same score. Okay, take note. So if what you have here is what is here, you get the M1 because you end up. But next time, make sure so that you write less and you save time. Okay, so on this note, okay, thank you very much for your time, your patience. Okay, God bless us all.